So let's learn how to work with multiple linear regression in R. We will use, again, the same data set, so I just copy and paste it from the previous script, where we have a people data with 32 variables and 32 objects and 32 observations and 12 variables. Okay. So let's start with learning how to make a MLR model and how to investigate the regression coefficients, how to make predictions, all that kind of things. And in this case, I would like us to make a model using two variables, actually, three variables. It's the same as I used in the lecture. It's a region, it's age, and it's a sex. Okay. So let's do it. Actually, the function is absolutely the same. It's lm, but you just need to specify several variables. So that's how to do it. You say lm, then your y variable, it's income, then the relation, then which variables you want to take into account. You want to take into account age plus region plus sex. Okay, so it's relatively simple, and you can see that it's similar to what we did in ANOVA, right? When we wanted to take into account several factors, then you say where to get the data from. Okay, so I'll just show m. So in this case, we got a model. You see that we have three slopes, one for each variable, and then we have an intercept. So that's the age, 805. Then we have this region, minus 3,616. Then we have sex, minus 175. Okay. Then if you like, if you look at the summary, you can see the summary is also very similar to what we had before. That's the most important table, right? So you can see that this is the p-value, that the corresponding coefficient in the population is equal to 0, right? So that's our null hypothesis. So you can see intercept is not important, and the sex also has a very huge p-value, a very large p-value. So it seems like we don't have any evidence that sex influenced the salary, the income, at least in this particular population. And then we can see a clear effect from age and region. So we have 3 stars here. It means that the p-value is very small. Okay, that's the r squared. So this is the real r squared, the 0.9521, and this is the adjusted r squared, 0.947. But if we round both to 2 decimals, it will be the same, 0.95. And again, the f statistics and f test tells us that the model is the model is good. The model is good. Okay, it's at least it's sound. It's not a total nonsense. Okay. Now look, we have 28 degrees of freedom instead of 30, because now we calculate 4 regression coefficients instead of 2, of course. Then let's look at the confidence intervals for the regression coefficients. Conf_int, and then the model. Okay, so these are the confidence intervals. So you can see that intercept can be negative and positive, age between 720 and 890, and then we have also the regression coefficients, the confidence intervals for the region and for the sex. Then you can see that for the sex it can be negative, can be positive, and it's quite a big spread here. Okay. Now how to make predictions? Well, first of all, you remember, if you want to make predictions for the same data as you use for the calibration, the model, you just simply use function predict and the model. Let's look at the predictions now. Again, we will just combine together a column with the real salaries, with the real income, and the column, the vector with predicted values. So let's see what we get. Then again, let's take Lars. You remember we have about 6,000 difference. Now the difference is only 3,000. So the predictions is much closer. Here we have also 3,000. Here we have less than 1,000. Here we have less than 1,000. So the predictions are much better when we take into account all factors. Okay. Then we also, of course, can make the plot for predicted versus measured values, yp. Let's take the real values first. Let me make a vector with real values. So yeah, I don't use the data frame every time I want to make this. So income. So this is y, and then I will make a plot for y and yp. Y, the real y values and the predicted y values. Then you can see that indeed they lie very close to a straight line. If I add this line, the ideal line, you can see it even better. So the predictions are very good. Okay. Now let's look at the residuals. So we have residuals, m, and let's look at the plot first of all. the residuals versus real y values. So we have plot, we have y values, real y values in the x coordinate, and then residuals as a y coordinate. Okay, so I will add this line, AB line, horizontal equal to 0. Okay, so that's the residuals. Now you can see that indeed they are more scattered on this plot. So if we compare it with a simple linear regression, we have almost no patterns, no systematic patterns at all. The residuals look much more random. And then if we make a cuckoo plot and add a cuckoo line, so that's how they look like. So they look pretty normal. If we make a Shapiro test, you can see that the p-value is even a little bit larger. Before we had the 0.17 in the simple linear regression. Now it's 0.21. So we can be sort of sure that the predictions, the residuals are normally distributed. Okay. Now let's learn how to make predictions for a new data set. You remember we also use function predict, but then we need to provide a data frame with the new values. Okay. So let's make a new predictions. Let's say we need to make a prediction for our model, then data frame. And in the data frame, we have to provide values for every of the 3 variables, and then we have to use the same names of the variables as in the model. You can see age, region, and sex. Let's say we would like to predict a salary for a person who is 30 years old, and then the region, for example, -1, it's a Scandinavia, -1, and the sex, for example, is a male, female. Okay. So if we show the value around these 2 lines, so that's the predicted salary, 27,303 euro. Let's calculate the same, for example, for the region equal to +1. Then you can see that there will be a difference of about 7,000 difference. But again, this is the sample, right? So first of all, it's an average, and then remember that there is always uncertainty, so you have to take into account the uncertainty of predictions. And then similarly, if you want to make predictions for several values, you need to provide a vector of values. For each of the variable, you need to provide a vector of values. These are the major steps you always use when you work with MLR models. So you look at the model, you make a model, you look at the summary, look which regression coefficients are significant, which regression coefficients are not significant, analyze residuals, analyze the prediction quality, and make new predictions if necessary. Right? Now let's learn how to visualize the model. And in this case, actually, it's not that easy, because if you want to visualize the model, you have to create a matrix of x values, x1 values, matrix of x2 values, and then you need also to make to calculate y values for every point in this matrix. It's a little bit tricky. However, I'll show you that actually it's possible. Okay. In order to do that, you have to learn how to write functions. So remember, we have a function which, for example, you can provide any arguments to this function and get a value. Okay. Let me start with not how to make how to visualize it, but just show you how to make a function, how to write a function. Let's write a function f. Let's write a function, for example, mySum, that's the function name. Then we say it's a function with 2 arguments, x1 and x2. Okay. And then inside this function, we do something with this x1 and x2. For example, s equal to x1 plus x2 plus x2. Okay. And then return s. So it means that function will take x1 and x2, calculate a sum, and return this sum as a result. Okay. So we can run this code, and you will see that in the global environment, now you have a new block. Let me show you that. It's called functions. So now your function is in memory. It means that you can reuse it. Okay. It's very common to use functions for something that you have to do several times. For example, some calculations or some plots. So now I can, for example, say show mySum 10 and, for example, 23. Okay. So it will show you 33 because it calls the function mySum, puts these arguments 10 and 23, so x1 will be 10 and x2 will be 23. Then the function returns the results of the sum. For example, show mySum, I don't know, 11 and 11. So we got 22. So this is how functions works. How functions work. Now, what we need to do, we need to make a function that will calculate a simple thing that will, for any given variables, it will calculate the y. So it will predict the y. Okay. So that's how to do it. F equal to function x1, x2, and the model m. Okay. Then we know how to make predictions, right? So we just take y equal to predict. Then we have data frame, m first of all, data frame. And then, for example, let's make it h equal to x1, and then region equal to x2. Okay. And in this case, you see, I don't use sex. I know that sex is not important for prediction of the income. Therefore, I will just make a new model here. So I will just make a new model where I take into account only two variables. So income relates to age plus region. So I'll just write data equal to dA. So I'll just write. So that's my function. Okay. So for any given x1 and x2, it calculates the y value. So if I run it now look what I can do. For example, show f of let's say 36 and 1, and then the model. So it shows me the predicted value. Okay, f for 36 and -1, and the model. It shows me the predicted salary. So for any given, for any two arguments, it just shows the predicted value. Okay. Now what is next? Next is the following. Let's generate a sequence for x1 and x2. So x1 will be our age, and then I generated a sequence. I start with 20 years. I end with, for example, 60 years. And let's say that I would like to generate, I don't know, 50 values. Okay. Then I do the same, x2 equal to sequence. In this case, it's a little bit confusing because we know that the region has -1 and +1. But for regression doesn't know that region is discrete. Regression assumes that region is continuous variable. So that's why I do it this way. So from -1 to +1, and then also not sequence, of course, length, and then length here as well. So the length, the number of the sequence is 50. So we have 50 values between 20 and 60, and 50 values between -1 and +1. Now look how I calculate y. I use a function outer, x1, x2, f, and m. Okay. What outer does? Outer takes into account all combinations of x1 and x2, make a matrix with this combination, and then generate y values for this matrix. Okay. So let me show you how it looks like. Look, now y, it's a 50 by 50 matrix. So it takes all the combinations into account. And then for every combination of x, you have a salary. For example, you have 36,000 here, or 36 years here. And then you have -1, -0.8, and so on. So all combinations of region and age. Okay. Now we can use this matrix to make the plots. If you want to make a surface plot, it's a function pairs that does it for you. Just provide the three arguments, x2 and y, and that's your surface. You can see it here. Okay. So this is your surface. In my case, unfortunately, this surface plot in R is not very good because you don't see any. For example, the values for x1, you don't see the values for x2. But you can find another functions that can do it for you. Okay. You can rotate it using two angles, theta and phi. For example, if you write theta is 25 and phi, for example, is let's say 10, then let's make it, for example, blue. So you can see it like this. So it's rotated now, and it has as many segments, as many values we generated here. So now this surface is 50 by 50. Okay. But as I told you before, the better way to represent this is to use function contour to make a contour plot. So let me show you how to make a contour plot. The same arguments x1, x2, and y. Okay. And then you can see the contours. You can change the contour numbers by just providing this. For example, if you want 15 contours, you will have this 15 contours. Okay. Then if you look at the help, you can also find how to make different different tuning of this plot. Okay. And then you can see the salaries that corresponds to these contours as a number here. Then finally, if you want to make a colored plot with the contours, you need to use a function fillet contour. Then x1, x2, and y. So that's the fillet contour. You can see also now you can see the real value. So this is salary. You can see this is region, and then you can see the gradient, the color gradient, and the legend for the color gradient. Okay. Then finally, let's talk about how to take into account interaction. So we already know, let me just write it again. We already know that this way, we can create a multivariate model that, for example, show the relationship between a y variable and two x variables. In our case, it was h in region, okay? Data equal to dA. So that's how to make this model. Now, if you want to take into account interaction between two variables, you just add one more term that looks like this. It's h colon and then region. Okay, so in this case, we would like to see also interaction between h and region. Okay, let's look at the summary. If indeed we have any interaction, for example, in one region, the salary for different h is growing faster than in another region. So let's see that. Okay. So again, we see a table for the regression coefficients. You see, this is the slope for the h. This is a slope for the region. Now you see that the region is not important because we use this interaction term. And then this is the h in region. Okay. So it might be quite misleading when you use the interactions if you don't have actually the real interactions. Now let me make two plots. One using the interaction, one is not. So I'll just generate two y values using the same function that we used before. So this, let me use M1 and M2 here. The first model without interaction, the second model with interaction, and I will also use the y1 and y2 here. Then if I want to make my model works, my script works, I need to add y2 here. So okay. So I'll just run this again. So let me show the field counter plots for y1 and for y2. Unfortunately, this field counter function does not allow us to make two plots together, so I will just make them one by one and then show you them. So you can see this is the plot for the model with interactions. Then you can see that it's not the straight lines anymore, okay? So you can see some curvature here. If you get back, this is model with interactions, we see a straight line. So without interactions. So without interaction, straight lines. With interaction, a little curvature, small curvature here. Okay. So that's how it works in R. And now you can use all this knowledge to practice in your mini projects.